Hello and welcome to this video. In this video, I want to deal with a physical quantity referred to as momentum. So, being a derived physical quantity, we want to define it. What is momentum? Momentum is the product of the mass of an object and its velocity. First of all, it is a property of an object which is in motion. An object of a given mass, and this object is in motion. So when we multiply its mass and its velocity, we get momentum. That is where I want to start from. So you're going to say momentum is the product of mass and velocity. In symbol, momentum is represented by P is equals to M times V. Now, are the SI units. What are the SI units of momentum? The SI units of momentum are also derived. How are they derived? So I will say the units of momentum. This is how we write the physical quantity when we want to talk about its units. We put the symbol for the physical quantity in these square brackets, and then we look at the units of mass multiplied by the units of velocity. The units of mass is kilograms. The units of velocity is meters per second. So the SI units of momentum is kilograms meter per second, or Newton seconds. We shall see later how these units, Newton seconds, comes about. So, few things. Product of mass and velocity is momentum. We go ahead here and say that a momentum is a vector. It is a vector quantity. And you should remember that a vector is a physical quantity which has got both magnitude and direction. For example, let's assume that this one is a horizontal surface and we've got a mass here of 20 kilograms. That is a mass. It's moving to the right with a velocity of 4 meters per second. So, when we get its momentum, which is 20 times 4, which gives us 80 kilograms meter per second, or 80 Newton seconds, then we are going to say that it is in that direction. The direction of the momentum of an object, the direction of the momentum of an object is the same as the direction of its velocity. So if you know the direction of the velocity of the object, then you know the direction of its momentum. Now, saying that it is a vector, it is saying much, because we are going to use that aspect of the fact that momentum is a vector when it comes to getting the sum of when you are given a system of particles or masses which are in motion, and we want to get the total momentum of that particular system. We'll need to put into consideration that momentum is a vector. The other point that I want to emphasize here, while I'm still on the equation which is associated with the definition of momentum, is, first of all, we've already mentioned that momentum is a derived physical quantity, and any derived physical quantity must be defined, and there is an equation which is associated with that definition. Very important. The equation associated with the definition of momentum is this one here. So you need to recall it, because it's the one which stems directly from the definition of momentum. It comes directly from the definition of momentum. So you should remember that. Product of mass and its velocity, it's a vector, and saying that it's a vector means this much. Now let us look at two bodies with, if for example, I'm given that this object, 20 kilogram mass, is traveling with half the velocity, that is 2 meters per second, its momentum will be 40 because it will be 20 kilograms times 2 meters per second if its velocity is 2 meters per second. Therefore, you'll see that its velocity will be halved because the momentum, you'll see that the momentum will be halved because the velocity has been halved. So one of the factors which affects the momentum of an object is its velocity. Momentum is directly proportional to the velocity. When you double the velocity of the object, you're going to double its momentum. The other factor which affects the magnitude of the velocity, because first of all, when we say that a vector is a physical quantity with both magnitude and direction, is that this number here, 80 kilograms meter per second, it refers to the size of that physical quantity, the magnitude of that physical quantity. The arrow indicates the direction. So we are talking about factors which affect momentum of an object. One of them is the velocity, just like we have it in this equation. In fact, the moment you have the equation which is associated with the definition of that physical quantity, it's another way of telling you what are the factors which affect that physical quantity. So in this case, you can directly tell it is velocity and momentum. And just like we have said that the momentum of the object is directly proportional to the velocity, momentum of the object is also directly proportional to the mass of the object. That is, given two particles with different masses, the one with a bigger mass will have a higher momentum. For example, a small van and a truck moving with the same velocity, the truck will have a much higher momentum because its mass is very big compared to the small van whose mass is small. So understand, two factors which affect momentum of an object, its mass and its velocity. Of course, when the object is stationary, its momentum is zero. And again, that one stems directly from these simple definitions here. When the object is stationary, its momentum is zero. Suppose this object were to move in the opposite direction, its momentum will be, suppose it were to move in this direction with the same velocity, maybe u, 4 meters per second. Suppose that was the case and that this velocity is not there, now it's moving in the opposite direction. We'll find that its momentum will still be 80 kilograms meter per second, but to the left. The two momenta, the plural of momentum is momenta. TA, momenta. This momentum of 80 kilograms meter per second to the left is different from the momentum of 80 kilograms meter per second to the right. They are different, and the reason why they are different is because of the direction, although the magnitudes are the same. So there are three situations in which the momentum of an object could be different. Number one, momentum is said to change if its magnitude changes, even if its direction of travel remains the same, or the direction in which it travels changes although its magnitude remains the same, or when both magnitude and direction change. Those are three situations in which momentum of an object or any other vector is said to change. So those are the basics as far as momentum is concerned. In the next video, I'm going to look at how do we add the various, the momentum of various particles in a given system? How do we add them when we are given that momentum is a vector? So see you in the next video.